Hey gang, welcome back to another statistics video. Today we're going to be talking about confidence intervals. I'm your host, Mr. Klein, and let's talk crime. C-R-I-M-E. Crime. And specifically, we're going to be looking at the crime rate today and trying to construct a confidence interval. Now you've noticed that all the data that we're working with here is from the state of Michigan. We're going to assume that the state of Michigan is like a sample that can reflect the United States in general. And so what we're looking for is a confidence interval for the average crime rate. In order to do that, we're going to use column D here. And I've created a new tab at the bottom of the page. You hit the plus sign if you want to make a tab. Try it. It'll work. And then I called it CI for confidence interval. And here's the information that we're going to need. The formula for the confidence interval for a mean is x bar plus or minus t multiplied by the standard deviation divided by the square root of the sample size, which means we need x bar, we need standard deviation, we need sample size, and we need t. Review from last time, I get x bar by typing in equals average, and then I enter this formula right here for the cells that I'm interested in studying here. Okay, so I'm going to go ahead and copy those. And then here I'm just going to type in standard deviation of those cells, and then count of those cells. Make sure you know those formulas. The next thing that we're going to do is we're going to construct three different confidence intervals. A 90%, a 95%, a 99%. Note the decimal places. Right here for t, what we have to do, I'm going to show you the formula on another page. If I can find the other page. Yeah! Sure, enjoy! Is you're going to type in t dot inverse, and then you're going to put the lower tail, and then you're going to put the degrees of freedom. Okay, so here we go. It'll be equal to t dot inverse of. Now, the way that we find the lower tail is we do 1 minus the confidence level and divide by 2. And then our sample size, or our degrees of freedom, are going to be this number right here minus 1. All right, now notice that it gave me a negative value. I don't like that, so I'm going to make it positive just by sticking a negative in here. And there we have it. There's the t-score that we want. Now, next thing, I'm a lazy bum. I would like to be able to copy this formula and just enter it in here and here. The thing is, I want that D5 to change because that came from the confidence level, but I don't want the B6 to change because that came from the sample size right here. Oh, did you catch that? The D5 we want to change. We want it to become D6 here and D7 here because it refers to the confidence level, which is changing. But, I know I'm repeating myself, but it's important, the B6, we want that to stay the same in each cell because that is the sample size. We want to stick with that cell. So here's how you do that. You enter $, and those two $signs there are going to fix the cell. So copy that, paste it here, paste it here. There are our t values. Okay, moving on to the margin of error. Now the margin of error is t multiplied by s divided by square root n. So right here I'm going to say, okay, my t value for a 90% confidence interval is this number multiplied by s, which is this number, divided by sqrt will give you the square root, parentheses of my sample size is this number. Now, I'm still a lazy bum, so I want to take that margin of error and I want to copy it here and here. But note, I want the t-value to change from this to this to this. So that's E5 I want to become E6, E7, but I don't want the S to change, so I want this to stay B5, and I don't want the N to change, so I want this to stay B6, enter our friend, the dollar sign. You'll notice as you scroll up, look at that E5, E6, E7, but nothing else changes. Okay, moving on, let's go to the lower bound. The lower bound is equal to the X bar minus the margin of error. So I'm going to take equals X bar, and then I'm going to subtract from that the margin of error, which is hanging out right here. There's my lower bound. I want my upper bound to do the same thing, except for this time X bar, we're going to add the margin of error. There's our upper and lower bounds for the crime rate at a 90% confidence interval. Now, again, if we want to copy these, we want the margin of error to change, but we don't want X bar to change. So I'm going to take the cell where X bar is stationed and stick in the dollar signs here. Dollar bill, copy and paste. There are our confidence intervals. So we would take this and we would interpret those two numbers to say, I am 99% confident that the mean crime rate, which is crimes per 1,000 residents in a U.S. city, is between 2.3 and 3.3 crimes per 1,000 residents.